Positively Perfect Problem Solving presents Defining Expressions and Equations. There are a lot of words that we use going forward in this class that describe equations and expressions. And going forward, I'm going to be using this language to talk about what we learn. So we're going to talk about 6 different words that come up that I'm going to expect you to know when I say them in videos or in class, okay? So the first one I need you to know is the word constant. A constant is any number that is on its own. So if I look at this little, I've given you an equation down here, 3x plus 5 equals 20, and all of these words we use can just basically be assigned to this type of thing. So I'm going to move this up just a little bit. So in 3x plus 5 equals 20, we actually have 2 different constants. So the 5, because it's on its own, we can call it a constant. The 20 is also a constant. Let me rewrite that so we don't go off the page here. So 20 is also a constant because they're all by themselves. Just a 5, just a 20, those are constants, okay? The next word is variable, which is something you've heard a lot, but a variable is any symbol that stands for a number we don't know yet. So in this example, I have one variable, and that is the x. Okay, not so bad, right? A term, and this is one that is probably the most important in this whole lesson, a term is either a single variable by itself or it's numbers and variables multiplied together. Terms tend to be separated by plus and minus signs. So I'm going to put that little hint here that terms are separated by plus or minus signs. So if I look at my example up here, and maybe I can get a highlighter that is the color I want. So the 3x, the 5, and the 20 are all actually terms. So this, even though 5 and 20 are also constants, they're also considered terms, which I know is strange, but both of these words can describe the 5 and the 20. Additionally, this 3x right here is also a term because it's a number and a variable multiplied together. So 3x is also a term. And notice that the 3x, 5, and 20 are all separated by a plus and an equal sign. So they are just separated by operations, okay? So 3 terms in this example. The second most important word that we use in algebra is called a coefficient. Now a coefficient, the definition is a number used to multiply a variable. Sorry, my pen is kind of skipping there. A number used to multiply a variable. And something else we kind of give a hint for is that it's usually a number in front of a variable, right? So for an example, if I have 6x, then 6 is my coefficient. another example, if I have just x by itself, then even though you don't see anything in front, there's always an invisible 1 there. So I would say 1 is my coefficient. Okay? Sometimes we even see things like this, where I've got ax. In this case, a represents a number, so we can call a coefficient. So there's 3 different ways we can see coefficients. In terms of this example, the 3 right here, that is my coefficient for the x. Now I don't have any other variables in this example, so I only actually have one coefficient here, which is 3. Okay? Really important to understand what I mean when I say coefficient. The last 2 words are words that you should know pretty well, and that's expression and equation. Okay? I'm going to use black for this. So expression, the real definition are just terms, like the 3x, 5, and 20, terms that are grouped together and they show value of something. So when I look at this right here, I know that it has an equal sign in it, but this guy right here, this 3x plus 5, this right here that I'm underlining, that is actually the expression. Technically, this 20 is also an expression. It doesn't have anything else with it, but it's still an expression. It shows a value of 20. Okay? So usually we can also think of it as something with no equal sign. So this has got 2 expressions because the equal sign separates them. Which leads me to talk about the word equation. Equation basically says that there are 2 expressions that are equal to each other. So when I look at this example, I do see an equal sign, so I automatically know it's an equation. But I need you to understand that it's an equation because you've got 3x plus 5, that expression equal to 20, which is another expression. So altogether, that makes something an equation. Okay? I don't know why that didn't finish typing equation. Okay? So you can also remind yourself that it has an equal sign to help you, okay? But I'm going to expect you to know that there's 2 equations in front and after the equal sign. Okay, so that's all your vocabulary that we're really going to use throughout this year. Extremely important, okay? So when you come to me and I say, what's the coefficient, and you say that I don't know what that word means, I'm going to refer back to these notes to help you remember because we need to commit to knowing this language, okay? So what's this language really used for? Well, it's used for a lot of things, and I'm going to show you a couple examples here today. When I ask you in an equation and expression, I'm going to ask you to identify these parts of expressions the way I just showed you. So when I look at this first item right here, the first thing I notice that this whole thing is an equation. It's got an equal sign. Because this whole thing is an equation, then I also know that this guy right here and this guy right here are expressions. But we can be a little more specific. The first thing I want to be specific about is I want you to tell what all the constants are. So in this example, my constants are the 4 and the 2. The 2 is also an expression. Sometimes they can double up. So 4 and 2 are my constants. They have no variables attached to them. The other thing that I want us to be able to identify are the terms. And I'm going to use a highlighter for that. It's a little bit easier. So the terms are going to be the 2x squared, the 4x, the 4, and the 2. So we have 4 terms. 2x squared, oh, I wrote an a, not an x, 2x squared, 4x, 4, and 2. Okay, those are all my terms separated by plus signs and an equal sign. Okay, now I need to know the coefficients. Oops, I don't know why that still stayed green. That is interesting. Okay, coefficients. Okay. My coefficients are going to be this 2 and the 4. It's the 2 and the 4 because they are in front of variables. They are in front of the x. 2 and the 4 are coefficients. Okay. The last thing I want to be able to identify are the variables. So this particular equation only has one variable, and that is an x. Okay, I don't see any other variables in this problem, so these are all of the things I want us to be able to identify. Okay? This next thing, when I look at it, I notice it does not have an equal sign, so there actually is no equation here. However, I do notice that there's one big expression. I'll do that on the top to stay the same. So this whole big thing right here is an expression. Okay? So I've got 3 terms. Let me put that in green. Sorry, I'm moving slow here. So I've got 4 terms. I've got negative 4a. I've got 2b, 3c, and negative 1. That minus sign stays with the negative. That's super important. So negative 4a, 2b, 3c, and negative 1 are my terms. My coefficients are going to be the negative 4 in front of A, the 2 in front of B, and the 3 in front of C. I only have one constant. And remember, keep that negative with the negative 1 here. That's my negative 1. And then when I talk about variables, this problem actually has 3 of them. It's got an A, a B, and a C. So being able to identify parts of these expressions and equations is super important. There's a lot of stuff going on in here. All right. The next thing is I want us to be able to notice is I want us to be able to talk about like terms. Okay, because sometimes terms we have to simplify things, and we can simplify things that are like. Things that are like are things that are the same. So if 2 people are alike, maybe they both like the outdoors. Maybe they both like to exercise. Things like that. So in the same way, in algebra, we have things that are very similar. So like terms are terms. Oh, where's my pen doing here? They are terms whose variables and constants, oh, not constants, I'm so sorry guys, whose variables and exponents are the same. So when I look at terms that are alike, I want to look at the variable and I want to look at the exponent. I don't care about the coefficient. So when I look at this table right here, I see negative 2x and x. Is the x the same as x? Yes, so these are like terms. The next one, I'm going to look at the variables. Is the a the same as the b? Nope, so these are unlike terms. 2c squared and negative c squared. Is c squared the same as c squared? Yep, so they are like terms. Y squared and y are unlike. Even though they both have a y in them, one is squared and one is not. So they can't be the same. They have to have the same variables and the same exponents. The last one's a little bit trickier. They both have an a and an a squared and a b squared and a b. But because the a in this one and an a squared in this one are different, they have to be unlike. You can't have an a squared and an a in two terms and they be alike. Even though they both have a and b, they have to have the same variables. So this leads into talking about combining like terms. Okay, so when you look at an expression, we always want to simplify. So when I see an expression that has a bunch of terms in it, I always want to check to make sure that I have all the like terms together. So the first step of this process is to find like terms. So to do that, I really like to use color, and I encourage you to do this on your work. So I'm going to color the same terms I see that are the same. So negative 2x and 3x are like, positive 2x and 3x are like terms. And to combine them, all you have to do is add up the 2 and the 3. So 2x and 3x are going to give me 5x. And then I like to cross them out when I've combined them. So 2 plus 3 is 5. And then this negative 5 is all alone, so I'm just going to bring it down. So that's how I simplify that expression. Let's try the next one. Oh, my bad. Let's go back. Sorry. Let's try the next one. I'm going to highlight. Guys, my pen is being a jerk today. All right, I'm going to highlight like terms. 3b and negative 5b are like terms. So I'm going to add those together. So 3b and negative 5b is going to give me negative 2b. And then my other like terms are going to be 6 and negative 2. So I'm going to combine them and do 6 minus 2, which is going to give me plus 4. Okay. Again, color is extremely helpful. If you don't want to use color, you can also use shapes. So I see that 5c and negative 8c are like terms. Okay. Then 12f doesn't have a like term. I'm going to use a triangle. And negative 3 doesn't have a like term. I'm going to use a circle. Okay, so now I see that 5c and negative 8c are like terms, so I'm going to get negative 3c. I'm going to cross them out. I'm done with them. 12f is alone, so I'm going to have 12f here. And negative 3 is also alone, so I'm just going to bring it down here. One thing I want to note is that when you're rewriting expressions, you always want to keep it in alphabetical order. Like I wouldn't want the f to be in front of the c. I'm not going to mark you wrong, but it's the way professional mathematicians do this, so try and keep it in alpha order. I like colors much better than shapes, so 8x, 6x are like terms. So 8 and 6 is going to give me 14 and bring down the x. They cancel. The next like terms I have is negative 12y and positive 8. And when those are added together, I get negative 4y. I cross them out. And then the last term I have is a 4. So I get negative 4, I get 14x minus 4y plus 4 is my final answer. You'll know it's final answer if you have no like terms in your answer. If you have like terms in your answer, you've done something wrong. And the last one, even this one is a little different. I've got now x squared, but that's okay. I'm going to line that up with the negative 6x squared. So now when I add these together, I get negative 4. I can write that 4 better. I get negative 4, and then I have just keep the x squared. Don't change the exponents. It just stays x squared. And then I've got negative 3 plus 2, which gives me a negative 1 as my final answer. Okay. The last one I want to show you is just a longer problem. Okay. When you have a really long problem like this, you need to organize your like terms. Colors and shapes are vital here. So I'm going to highlight. So I'm going to highlight the x squareds first. I have a 5x squared here, a negative 8x squared here, and a 4x squared here. When I add those two together, I've got 5 and 4 give me 9. Then 9 and minus 8 gives me a positive 1. So I'm going to have a 1x squared there. Then I'm going to cross these out because I'm done. Now I'm going to look for other like terms. I see a 4x, I see a negative 7x, and a negative 8x. Now you can of course use your calculators. I'm doing it in my head, but you can use a calculator. Negative 8, negative 7 gives me negative 15. Negative 15 plus 4 gives me negative 11. So this becomes minus 11x. And then I cross them out because I've used them. The last then like terms are going to be the 8, the negative 8, and the negative 5. Well, 8 minus 8 gives me 0. So I can just cross those two out because it's 0. And the negative 5 just gets brought down. Do you see my colors? Do you see how I've crossed things out? If you come up to me and give me an answer and I don't see any system of organization and you've got it wrong, we're going to have a conversation, okay? Because organization in math is the one reason a lot of you are making mistakes. You're trying to do things in your head. You're trying to be quick. I don't care about quick in here. I care about getting things correct. And I know that if you take a mastery and you don't get things correct and you don't have anything organized, that's on you for not taking your time. Okay, so I need that to happen in this lesson, especially for some of these questions you're going to see in your practice. All right, good luck today and start asking for help. Okay, good luck.